So in this session we are going to discuss important compounds of hydrogen. So as you can see on the screen, hydrogen forms n number of compounds with other elements. So the most important ones are mentioned here. So hydrides, water, hydrogen and heavy water. These four are the important compounds of hydrogen. Okay, so one by one we will discuss. First we will take our discussion to hydrides. So hydrides are nothing but compounds of hydrogen with metals and non-metals are called hydrides. Okay, so if hydrogen forms compound with metal, or if hydrogen forms compound with non-metal, then those are known as hydrides. Okay, if specifically if hydrogen forms bond with metal, then those are known as metallic hydrides. If hydrogen forms bond with or compound with non-metal, then specifically they are called as non-metallic hydrides. Okay, so these are about hydrides. Then depending upon the electronegativity of the metal or non-metal and nature of the bond between the metal or non-metal and hydrogen, the hydrides are classified into three categories. See, from the first definition we understood that if hydrogen forms compound with metal, or if hydrogen forms compound with non-metal, then those are known as hydrides. So depending upon the electronegativity of the metal or non-metal, so depending upon the electronegativity of metal or non-metal and nature of bond between metal and hydrogen, hydrides are further classified into three categories. One is ionic hydrides, next is covalent hydrides, then interstitial hydrides. Okay, so depending upon the electronegativity and nature of bond, hydrides are further classified into these three categories. One by one we will discuss now. So first, ionic hydrides. Ionic hydrides, these are formed by elements of group 1 and 2 except beryllium and magnesium. Beryllium, magnesium ಬಿಟ್ಟು ಬೇರೆ ಗ್ರೂಪ್ಸ್ ಜೊತೆ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಅನ್ನು ಫಾರ್ಮ್ ಮಾಡಿದ್ರೆ those are known as ionic hydrides. Okay, see for example sodium hydride and lithium hydride, isn't it? These are group 1 and 2 elements, right? So these are white colorless solids having high melting point and high boiling point. Yes, see, because since the bond between group 1 element and hydrogen is ionic in nature, generally ionic bonds are strong in nature, right? Ionic bonds are strong in nature, so if the bond is stronger, obviously boiling point and melting point will be higher. So that's why ionic hydrides possess high melting point and high boiling point. Can be easily decomposed by water, carbon dioxide or sulfur dioxide. See, these hydrides, sodium hydride or lithium hydride, can be broken or decomposed easily with the help of water or carbon dioxide or sulfur dioxide, and they are strong reducing agents. Yes, the sodium hydride, lithium hydride, or we have other ionic hydrides like we have lithium aluminum hydride, LiAlH4, or we have sodium borohydride, NaBH4. These are all ionic hydrides. Okay, these are all generally strong reducing agents. So we use these ionic hydrides to reduce some other compounds. Okay, or we use these ionic hydrides as strong reducing agents. The next is molecular or covalent hydrides. These are formed by elements of p block having higher electronegativity than hydrogen. Yes, see, p block elements generally carbon, silicon, phosphorus. We have n number of p block elements, right? So generally molecular or covalent hydrides are nothing but hydrides formed with the p block elements. Okay, those are known as covalent hydrides or molecular hydrides. So generally we can take some examples like CH4. CH4 is an example of molecular hydrides. NH3 is an example. Okay, CH4 is a covalent hydride, or ammonia NH3 is a covalent hydride because carbon is a p block element, nitrogen is a p block element, and carbon possesses higher electronegativity compared to hydrogen. Nitrogen possesses higher electronegativity compared to hydrogen. So any compounds or hydrides formed with the p block elements which has higher electronegativity are known as covalent hydrides. So again, covalent hydrides are of three types: electron deficient hydrides, electron precise hydrides, electron rich hydrides. Okay, so deficient means less. So electron deficiency, in these hydrides you will come across electron deficiency. In these type of hydrides you will come across electron rich, I mean excess of electrons. Okay, more number of electrons in hydrides. In this category you will observe optimum number of electrons. That is, you can understand this when we take examples. Okay, so one by one we will discuss now. First, let us start with electron deficient hydrides. These are the hydrides which do not have sufficient number of electrons needed to form normal covalent bonds. Example, boron trihydride or boron hydride BH3 or aluminium hydride. So take BH3 as an example. Okay, see here you can see boron H3 BH3 H H H. Here boron H H H. See, this molecule is B2H6 molecule. B2H6. How you got B2H6? By the combination of two boron hydride BH3 BH3, you will get B2H6. Okay, you can observe B2H6 molecule here. This is an example of electron deficient hydride. Why? Because see, boron has valence electrons 3. Same way, this boron also possesses 3 valence electrons, and we need to accommodate 6 hydrogen for 2 boron molecule atoms. So I will accommodate like this: hydrogen, 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 hydrogen. Okay, so every single hydrogen possesses one electron each. So you will get one single bond, you will get single bond, you will get single bond, single bond, single bond, like this. But here you can observe, here there is no electron with boron atom to form bond with hydrogen. Okay, so here also there is no bond electron with boron to form hydrogen, but this molecule will form a special type of bond called as banana bond. Okay, so these things not required to you, but what you have to understand from this diagram is, even though boron has lesser number of electron with it to form bonds, okay, molecule will exist or molecule will form a new type of bond. Okay, so these hydrides possess or do not have sufficient number of electrons with them, but they will form covalent bond. Even then they will form covalent bonds. So such hydrides are known as electron deficient hydrides. Then electron precise hydrides. These are the hydrides which have exact number of electrons needed to form normal covalent bond. Have exact number of electrons. Okay, for example, best example is methane CH4. Carbon possesses 4 valence electrons, hydrogen possesses one valence electron with each of them. So you will get 4 bonds, and when you count all the electrons you will get 8 electrons. That is octet, that is stable, right? So in this case you can observe this carbon has exact number of electrons which are needed to form covalent bonds. Okay, so in exam just you can write the definition and you can write one example, no need to draw these things and all. Okay, next, electron rich hydrides. These are the hydrides which have greater number of electrons than required, greater number of electrons than required to form normal covalent bonds. For example, hydrides of group 15, 16, 17 forms this type of hydrides. Okay, just you can remember only single example, that is ammonia NH3. So in NH3 you can understand, see, nitrogen has 1, 2, 3, 4, 5, 5 valence electron. Okay, nitrogen has 5 valence electron. So each hydrogen has one valence electron. You will get single bond, single bond, single bond here, and extra 2 electrons will be remained as lone pair of electrons in case of ammonia, isn't it? Nitrogen has 1, 2, 3, 4, 5, 5 valence electron, and each hydrogen has one valence electron. So you will get 3 single bonds like this, and one lone pair will be extra with nitrogen. So since in this molecule we can observe extra pair of electron, so this hydride or ammonia is an example of electron rich. Okay, because here you can observe greater number of electrons than required. ಬೇಕಾಗಿರೋದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ, ಅದಕ್ಕೆ ಇದು ಎಲೆಕ್ಟ್ರಾನ್ ರಿಚ್ ಹೈಡ್ರೈಡ್ಸ್ ಅಂತ ಹೇಳ್ಬೋದು. Then next, moving on to interstitial hydrides. Interstitial hydrides are nothing but transition metals and rare earth metals combine with hydrogen to form interstitial hydrides. Transition metals means D block elements. Okay. Rare earth metals means generally F block elements. If hydrogen forms bond with D block element or F block element, then those type of hydrides are known as interstitial hydrides. So their properties are as follows. They exhibit metallic properties and are powerful reducing agents. Okay, so this is not needed to you. Okay, you can strike out this. Just you have to remember, interstitial hydrides are metallic in nature and they are powerful reducing agents. And one extra note you have to remember is metals of group 7, 8 and 9 do not form hydrides, and this region of periodic table is called as hydride gap. Okay, you have to remember this. See, metals of group 7, 8 and 9 in periodic table will be like this. Okay, this is S block, this is D block, this is P block, and at last you will get F block. So this is group 1, group 2, group 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the metals of group 7, 8, 9, the group 7, 8 and 9, these three groups, okay, do not form hydrides. These are known as, these groups are known as hydride gap. Okay, you have to remember that. So I hope by the next class, I hope you understood these things. By the next class we'll start with water, and then we will discuss hydrogen peroxide, and then we will discuss heavy water. Okay, so now we will wind up the class and I will continue in session 4. Thank you.